Okay, good. So I hope that gave some motivating examples and evidence, and happy to take further questions on that as we go forward. So I think there's, I think you're, well, as always, I welcome you to jump in, and I think there's a lot more, there are a lot of questions you might want to ask. There are some that I might even have answers to. Don't hesitate. Yes?
One question. So I was thinking of this graphic, so to say, employment share, both in the States and in Europe.
Yeah.
More or less the same pattern. The question is if these individuals, who lost their shares,
Yeah.
so
What happens to them?
except for the rich that pursue more, or they just give up even earlier.
Well, so that's really a question about, the mapping between sort of skills and tasks, right? And so you can think of, for example, that, okay. So take, for example, that you might have, let's say that you can think of your tasks as being a vector of efficiencies at different activities, right? So let's say, your gamma, your lambda I, right, is equal to your, some, lambda I1, lambda I n, or let's say k, where k is the number of tasks that you might in this vector. And if you wanted to specialize, right, you could say, okay, well, let's just think of there being 3, right? So you could have lambda I equals lambda A, lambda B, lambda abstract, lambda R, and lambda manual, right? And then those might be, if you devoted all your time to one of those other activities, those lambdas would be the sort of maximum amount of output you could produce, right? And then the question is, how do you want to allocate your time, right? And it's going to depend upon what are the market prices of these different things at different times, right? So for example, you could say, well, if I'm a person who's, can you guys see over here? Or is this too far over? You can see, okay. So you could say, so you could imagine, for example, there are different occupations that have different returns to these tasks, right? So you could have, for example, Yj is going to be equal to, alpha j plus, gamma, gamma 1 time, yeah, all right, so gamma 1 times, so all right, let's do it this way. The wage of person or output of person I in occupation J is equal to alpha j plus gamma 1 times lambda AI plus gamma 2 times lambda Ri plus gamma 3 times lambda Mi plus some epsilon ij, right? And so imagine that you face a vector of different occupations, right, where these lambdas, these gammas, it should be a gamma, where these gammas differ across occupations, right? Some occupations might reward abstract skills, some might reward manual skills, some might reward routine skills, right? And then based on your bundle of characteristics, you might want to choose the occupation that gives you the highest wage, right? So you'd be maxing over J, right, given your vector lambda, which occupation you would take. So for example, just take this in a two factor case. Let's say there's or even a single factor case. Let's say this is the, your level of routine skill, and this is your wage, right? And let's say this is the wage in the, so this is Y of, in the clerical occupation, for example. So the more of the routine tasks you can do, the higher your wage would be in the clerical occupation. And then let's say let's say for a given level of manual task capability, right? This might be your wage in the manual occupation, right? Or so we'll call this in, we'll call this in a service occupation, right? So notice both of these are positively sloped, right? They both have increasing, you get a higher wage for higher routine capability, right? But they have different intercepts. And so depending on your level of R, right, there'd be some R star, whereas if you're to the right of this, you'd want to select into this occupation, right? And if you're to the left of this, you'd want to select into the service occupation, right? So the choice of occupation would be the upper envelope of these lines, right? Now, imagine what happens over time. So let's say, for example, this, the return to this routine task falls, right? So if that falls, both these lines are going to rotate, right? But this one's going to rotate by more, right? So this one's going to rotate further because this is most of the wage return is coming from the routine activity, right? So the new point of intersection would look something like this, right? So what will happen is you'll have self-selection again, right? So this occupation will grow in size, right? The manual occupation. The people who stay in the clerical occupation, right, will be people who are particularly skilled at it, right? Will be people who have the highest productivity in that task, right? And so the result is that you would expect to see people moving among occupations, right, as the set of tasks that are demanded in the labor market change according to their comparative advantage, right? So you're going to, I think a useful way to think about this is I have some vector of task capabilities. I choose my occupation that gives the best reward to my bundle of tasks, okay? Now, a few things about this deserve note. Okay, one is, and I'm making a bunch of assumptions in being able to write this down. One is that basically there's no law of one price for tasks, okay? Because I've said that these gammas vary across occupations. Right, now that's a really important assumption or claim, right? Because in general, when we write down models about skill demands, we usually think there's a law of one price for education, right, for skill. And the reason there's a law of one price for skill is because it's this fixed investment good, right, that generates a flow of quasi-rents, right, that are return on the sunk capital or the sunk time that you made in it. And so, in some sense, it has to be rewarded equally across sectors. If it isn't, then you would just reallocate labor until it was, right? And so if you have a one-dimensional skill, then clearly everybody's going to have to pay the same price for it. But now you have, imagine that you have skills that are bundled together. So let's say, let's take another example. Let's say you have 3 different tasks, but you could sell them element by element to the market, right? So I could sell my abstract skill task to one job, my routine task job to another job, and my manual task to a third job. Then there would also be a law of one price for tasks, right? Because every sector would have to pay the same marginal price for those tasks, or else you would just sell them to a different sector, right? But now imagine that there's indivisibilities, right? That you can't go and sell your skill in one thing to one job, your skill in another thing to another job, and so on, because you're basically constrained by proximity to do all these things at once, wherever you are, right? Well, in that case, what's going to matter is the sort of production function of output in that occupation, right? And there's not going to be a law of one price. What's going to be the case is that self-selection is going to create a condition where each person, is either indifferent between 2 occupations or strictly prefers one to another, right? So in other words, it has the constraint would be in equilibrium with no optimization errors, right? That each person is in the occupation that gives the highest reward to their bundle of tasks, right? The people will be self-selecting, so if one type of task becomes on average more important, right, more people will do it. And it gives rise to a couple of things. It gives you the 2 things that come out of that. And by the way, this is in the Otto Handel paper 2009, which is just an NBR working paper. It's called Putting Tasks to the Test. And there are 2 predictions that come out of this. One is that you can't have, this would imply that there are no dominated occupations. So, for example, a dominated. If you think of an occupation as being a vector of each occupation, so let's say gamma. This is the vector gamma j is going to be equal to alpha j gamma 1. Gamma 1j, gamma 2j, gamma 3j, right? So this is basically the set of rewards in that occupation, which is a constant term, and then these rewards. Now, why do you have a constant? This could actually be negative, right? It could easily be the case that if you enter an occupation with no capabilities, right, you do damage. Right? You know, drive a spaceship, don't know how to do that, negative output. Okay, and so it can't be so if you think about the set of occupations, so we have occupation J, J plus 1 through occupation J, capital, right? It can't be the case that there's one occupation no occupation can be vector dominated and still have employment. Right? Is that clear? Because if it is, it wouldn't satisfy the individual rationality constraint. It means that everyone in that occupation could switch to a different occupation and make higher wages. Right? So that's not a very testable implication, but it says you can't have any occupation, some occupation, J prime, where alpha J, gamma 1J, gamma 2J, gamma 3J are less than all of those values in some other occupation. Right? It also further implies, and this is perhaps more testable, is that think about think of this in the case of there only being 2 tasks and 2 occupations, or actually no, it actually doesn't have to be that. So imagine you just have 2 tasks, and there's gamma 1 and gamma 2, right? And these differ by occupation, right? So those are did I say gamma? I really meant lambda. There we go. Lambda 1, lambda 2, where these are the returns to tasks in these various occupations, and let's say, and you can think of alpha as being one of those returns if you want. It's got to be the case that if 2 occupations have employment in equilibrium, right, then it needs to be the case that, for example, we have gamma 1. It needs to be the case that either gamma 1j greater than or equal to gamma 1j prime, or gamma 2j greater or equal to gamma 2j prime, right? But it can't be both, because if it's both, right, no, you can't. Gamma 2, the occupation j prime, would have no employment, right? So more generally, you could say that basically gamma 1j minus gamma 1j prime times gamma 2j minus gamma 2j prime, right, is going to be less than or equal to 0, right, which is a definition of covariance, right? And so what that says is, let's say you have the ability to measure returns to tasks within occupations, right? And you could accurately measure how much each occupation rewarded each task. Well, it would have to be the case that there would have to be negative covariances among the rewards within occupations, or else those occupations couldn't attract employment. Right? So if a occupation has very low return to cognitive tasks, it must have relatively high return to manual tasks or routine tasks, or else no one would want to do it. Right? So there must be some occupation that rewards physical strength, some occupation that rewards abstract tasks, some occupation that rewards routine tasks, if people are doing those things in equilibrium. Right? So, but that's a very different prediction from the so-called law of one price for skills. Right? Now, did you have a question? Yeah.
So actually my question refers to the outcomes of the cost.
Yeah,
Can it really be that in equilibrium it's negative? So why should employers...
Well, no one gets employed at that level.
Yeah.
Right, sure. So, I mean, the constant current could be negative, but you wouldn't observe anyone producing negative output, right? Or if you did, they would hopefully be fired soon, right? I mean, there are people who produce negative output, right? You don't. That's not the expected output when you hire them, but it sometimes turns out to be the output for some short period of time. In Europe, actually, I think it can be equilibrium output. Okay, so so it's now. Let me say, what is the mapping between skills and tasks in this model, right? Well, it's not clear, right? Basically, you're going to have, the way I think about that is you might have skills. It might just be, it'd be fine to say, well, there are two skills, right? There's, college and non-college, and those affect your, expected productivity or your actual productivity in each of these task vectors, right? So you might think, well, college-educated workers have a comparative advantage in A, right? They have a lot of the abstract tasks. So all else equal, they're going to be self-selecting towards occupations that have high rewards to abstract tasks, right? And you might say non-college workers, might be relatively well endowed with both of these things, right? Sigma, gamma R and gamma R. And that might also be true for college workers, right? So it could be the case, for example, that college workers, in terms of task capabilities, they might, vector dominate, right? They might have, high capabilities in all three categories, right? But in general, in equilibrium, you'll just be seeing them use this one, right? Because that one's relatively scarce, right? That's the one to be rewarded. But then you might have people self-selecting, right, and this comes back to your question of a moment ago, right, as routine tasks, the demand for them diminishes, people are going to have to choose new occupations, right? There aren't going to be enough, or the wages will be too low, alternatively, right? So, you can compete with a computerized adding machine, you just have to take a really low wage to do it, right? And so you'll see people start to move into these occupations. But what's important about that, and why I want to stress that self-selection, is I don't want to think of there being people as I don't want to think of this as being a third skill, that some people can do this and some people can do that, so I need three skill groups. I don't think that's right. I think that it's logical to believe that most people who can do this one, right, could probably also do this one too, right? But they generally don't because it's not rewarded. Right? But that doesn't mean they couldn't move that way. So I think it's useful to sort of say there are skills. Those skills affect your capabilities in different tasks. The tasks that you choose to use in equilibrium are a function of the market prices or demand for those tasks, or not the task per se, but the bundle, the market, what the market will pay for your bundle of tasks, depending on what you're doing. Right? This is, so I want to say about that, yeah. So that's why, so when I typically, for example, my recent paper, the Otto and Dorn 2008, which is called Inequality and Specialization, the Growth of Low-Skilled Service Jobs in the United States, we basically have a model where you have workers self-selecting, you have high-skilled workers who are kind of inelastically doing this one, and then you have non-college workers who are choosing which of these things to allocate labor to based on the market prices of those activities. And then what's happening over time is that in general the market wage of the routine task is falling as it's being substituted for by capital. And then the question that the paper asks, and this was not a paper I was planning to talk about today and I won't spend much time on it, is does this declining value of routine tasks, does it imply kind of ever-increasing wage inequality between college and non-college workers? So sort of, as the price of routine tasks asymptotes to zero, does inequality grow without bounds? Or is there any moderating force that would tend to raise the sort of the gamma m, right, the return to manual tasks over time, so eventually what happens in the model is, demand for routine tasks collapses, right? Eventually almost no one's left doing them, so all the people who are not college workers have moved into the manual sector, and the question is, what happens to their wage? Well, I mean, the sort of natural answer that comes out of the paper is, it depends on the substitutability in consumption between these different types of outputs, right? So if you kind of, you might associate many of these things with sort of, with goods and with kind of high-tech services, and many of these things having to do with kind of low-tech services like haircutting, like food, like entertainment, right? And the question is, as the price of routine tasks falls, that corresponds to a rise in productivity, right? You're having declining costs of doing certain things, so incomes are rising. But at the same time, as incomes are rising, technological progress is unbalanced, right? Because it's concentrated in this set of activities and not in this set of activities. So whether wages rise in these things depends on willingness to pay, right, for these services as incomes rise. right? So it's exactly like the haircutters, right? Why are there still haircutters? Because as people get wealthier, their marginal valuation of haircutting seems to keep pace with income, right? So why are there people, doing house cleaning, right? When house cleaning is getting more expensive all the time relative to the cost of buying a new television set, right? Or relative to the cost of any other manufactured good you can get from around the world. Well, apparently, when it gets when you may tolerate a certain amount of mess, right? But in the limit, right, you're willing to pay an almost infinite amount for the first unit of cleanliness, right? I know I'm willing to pay an infinite amount for the last unit as well, but that differs across people. So the point is actually what's ultimately going to determine. Yes. So what is ultimately going to determine this basically harks back to Baumel's 1967 paper on unbalanced growth, right? Which starts off with the observation that basically, the symphony orchestra uses exactly the same number of musicians now as it did 300 years ago. There's been no productivity growth in symphony orchestras, and yet it's still the case that musicians make a living somehow, or at least some of them do. So it must be that sort of the income elasticity of demand is such that people are willing to pay for it, right? So our paper is sort of very closely related to that. Now he views that as a productivity crisis. It may be in terms of productivity growth, it may not be in terms of utility. Yes?
Well, some people think that you need inequality to sustain this kind of demand. In other words, you need enough people have these services are
right.
Superior goods, and you need to get some people getting rich enough so they can pay a lot of poor people to work for it.
Sure. Okay. So there's sort of several channels through which this might work, right? So one of them is essentially non-homothetic preferences, right? You get wealthier. You just want, you begin to value more and more personal services relative to consumable objects, right? That's one possibility. A second possibility would be changes in the market value of time, right? So even with, homothetic preferences, it might be that if the wage returns to skilled work rise, right, to skilled workers, then they want to spend less time in home production, more time in market production, so they'll pay people who are less skilled to do home services for them, right? So that's a second channel. So that's not a question about non-homothetic preferences. You don't need non-homotheticity. You just need changes in skill returns. And then a third possibility is, even without either of those things, it could have to do with just the elasticity of substitution and consumption between these two different types of outputs, right? So, I mean, just to give you, so basically if you want to look at the, let's see, so the non-homotheticity, I would say, so if you want, so non-homotheticity, the paper to look at, it really isn't a great one. There's Pissarides, and I think it's like, what? Yeah, in the AER, and that's recent, like 2008. If you want to look at market substitution, so basically this is substitution of buying home-based production so you can spend more time in the market. You could look at Mazzolari and Ragusa, 2008, and that's a working paper. And also Manning in 2004, which I think is in the Scottish Journal of Political Economy, not to be confused with the Journal of Political Economy. And these are, this is sort of the second hypothesis about changing value of time. And then if you want to look at the pure technological change with stable preferences and no household services, this would be Otter and Dorn, 2008. And let me say, it's not that I think that these other stories are irrelevant. I think this is, in some sense, the most parsimonious, right? It makes the fewest assumptions about mechanisms. It says, let's just assume there's stable preferences, and there's just a change in the technology in one sector. What's that going to do to equilibrium employment and wages, right? And it sort of solves out those cases. Now, I think But of course, these stories are quite plausible, but as it turns out, I don't think the evidence is very strong on either of them. There's no evidence, for example, that as top wages rise, services rise locally. Nor is there evidence that basically you see the households that have the greatest increase in labor supply, you see the greatest growth in service employment in that area. So I'll show you some evidence on that, right? But I think these are both plausible. I don't think they seem to fit the data all that well. So this one is more parsimonious. I think it sort of tends to fit, but that's a sort of an ex post judgment, not an ex ante one. Yes?
Yeah, do you think that there are transition costs for moving from number I to...
Absolutely, absolutely, certainly. And actually, I'll get to some of this later in the day and sort of looking at workers changing occupations, but I think this is basically unknown. I mean, sorry, let me say, so far, there's been no study that uses good, large representative samples to look at occupational change and the cost that it has for workers, right? So you would like to look at people doing one set of tasks, you'd like to see some exogenous shock to demand for those tasks, and then you'd like to see who stays, how their wages change, and who goes, and how their wages change. And what you would tend to expect, right, is that basically for the people who would stay would be the ones who are best at that task, their wages would decline, but of course average wages in that task might rise because you'd have a lot of people dropping out of the bottom, right? And then you'd expect them to go into some other activity which they would probably earn less at, but more than they would if they had stayed, right? But of course there's costs, right? This is, in this model, right, there's no occupation-specific capital other than these tasks, right? There's no firm-specific capital, there's no returns to tenure. But of course those things exist. In general, we know that when people lose employment, they lose wages, especially if they don't go back to the original industry or occupation they were in. So I think it's very much an open question that's very much ripe for exploration. So the stuff I will talk about briefly at the end of the day today about my paper with David Dorn that just uses age structure to look at this question, but we're just using repeated cross sections to look at people of different ages and what they're doing. We're not actually observing people as they move between cells. Questions on that? Okay, so let me so just to go back. So this is where so first of all, I think. As I've said already, skills are stock, tasks are a flow. I think that's an important distinction. This bundling, I think, is also really important in thinking about how wages are set, whether we should think of there being a price for each task or a price for an occupation. And then finally, tasks and self-selection. In the skills model, there's a law of one price for skills, occupation's irrelevant, right? You're rewarded for your skill. In this kind of, in a bundling setting, right? And by the way, the original bundling paper is Heckman and Schenkman in Restud in the 1980s, and that's like, it's pretty heavy going, but basically they're talking about how you have to think about a labor market where tasks are bundled, and it turns out it's messy, not surprisingly. But this model causes you to want to focus on occupations as opposed to skills. And it's an open question right now about how useful that will be. I don't really know. I think it's useful, but I will say that it's a very different direction from how the literature has gone. Right? The literature has been focused on skill as defined by education and what is the return to education. And so it's a very coarse view. It doesn't direct your attention at what people are actually doing. So the question is. If occupations are closely related to tasks, then you might actually want to focus specifically on what occupations people are doing and what wages those are being paid, or what wages are paid in those occupations, and that might be informative about this set of ideas. Okay, so let me kind of go through a few examples of that. So just to, so papers, so obviously I've talked about this paper. I mentioned Alexandra's paper, but that uses the IAB data, which is a much better task paper. I mentioned the Goose and Manning's 2007 paper about lousy and lovely jobs, the rising polarization of work in Britain. I just talked about the Otto and Handel paper, so I don't have to talk about that. So let me talk briefly about these two. So this one, Goose, Manning, and Solomon's, reverse the order. Goose, Manning, and Solomon's, Recent Changes in the European Employment Structure, the Roles of Technology and Globalization, which is basically an effort to understand those cross-country patterns of occupation growth that I mentioned a few minutes ago, and that they've put up the figure and table from their paper. And then I'll talk about the Faripeau-Fortin and Lemieux paper, although I won't spend time developing their model, but I'll interpret it a little bit. Okay, so here's Guzman and Solomons. So as I already showed you, this is their cross-national comparison of growth in occupations, and they, it's a little noisy, but clearly you see something that looks a bit like this U-shape. And so now they want to explain that. So what they do is they use the US ONET, that's the successor to the DOT, to classify occupations, or to classify tasks and occupations into, they call them abstract, routine, and service, which I call manual, but service is perfectly good. And they also try to classify offshore ability. Now, how do they do that, actually? So offshore ability, and this is something I haven't really mentioned so far, but as obviously is an important leading contender explanation or complementary explanation for routinization, right? So, things that are routine might be more offshoreable, right? Or it might be that things aren't being automated at all, they're just being offshored. And and so they may actually be very similar, they may be very different. So what they actually do is they collect data from the British newspapers of every mention of offshore ability in the last, I can't remember how many years, and then and each one of those gives a count of people laid off and the industry and the occupation, and they try to classify industry occupations according to these reported measures of offshoring. Now, that's not perfect, but it's interesting, and it's very difficult to know how to measure offshoring, right? Because in some sense, offshoring, no one may lose their job when you offshore, right? You just might create new work and do it overseas, right? That's an offshore activity. It would have been employment in the home country, maybe, if offshoring hadn't been available, or it might not have occurred at all, but we'll never know about it, right? So in some sense, they're trying to measure susceptibility to offshoring by examples of British work being offshored. And then they plot these things by occupations ranked by wage level, right? So I think these patterns are quite sensible. So this is the abstract task, right? And these are all standardized with mean 0, variance 1, right? So abstract task is monotonically increasing in wage levels. The service task, the routine task is inversely U-shaped, right? So it's lowest, that's right. So, sorry, that's not service. Sorry, that's the routine task, excuse me. Right, so the routine task is highest in the middle and lowest at the tails, right, which I think is what you would expect. And then the service task is basically highest at both tails. And that's the reason that service task is highest at both tails is it involves a lot of face-to-face interactions, right? So at the bottom end is primarily face-to-face interactions. At the top end, it's face-to-face interactions coupled with other abstract services, right? So lawyers interact with their clients, doctors interact with their clients, right? So it's kind of mixed. And then the offshoreability thing does look a lot like the routine measure, right? Yes.
What would the figures on the horizontal axis then?
Those are so those occupation wage percentiles. Oh, I see. ISCO occupations ranked by the 1993 merit. Excuse me. So these are occupation codes going from lowest wage occupation to highest wage occupation. I apologize.
So each figure stands for one?
Each figure stands for one occupation. That's correct. And they only have 21 occupations in their data set, right? So this is the cost of using harmonized data, right? Is that it gets pretty coarse. Okay. So that's the description of their data set. And then what they're going to do is they're going to run regressions of the growth of employment in terms of hours or log hours worked by country, by occupation, on these different measures, right? So in particular, the regression here for this board makes me feel really short. Okay.
It's not mechanized yet.
I see. No, that's good. No, I was totally thrown by that. The ones we have at MIT, you have these 3 panels, and they go in. Yeah. So anyway, I didn't even notice. Great. Okay, that's great. So basically, the regression they're running is, delta log hours. Or you can think of this as employment. So I'll call it Y in country J, in occupation K. Right, it's going to be equal to some alpha plus, hopefully we're going to have gamma j, so country dummies, plus delta k, which are occupation dummies, plus theta t, which are going to be time dummies. Now these are deltas, but you still want to have a common intercept then, right? And then this is going to be plus, basically it's going to be routine J. So the routine share, oh sorry, did I say J is occupations? J is occupations, K is countries. Okay, yeah, so we have occupation dummies, country dummies, time dummies, and then we have the routine share in country J, or sorry, overall, excuse me, so it's like some average for that occupation times T, right, so this would be plus beta 1 T plus beta 2 times the abstract activity in occupation J times T, right, plus beta 3 times the service activity in occupation J times T plus beta 4 times the offshoreability in occupation J times T plus epsilon J K, and I guess you could have a T. So if you want, if you're doing a single difference, this should just be one long difference, and then you could drop the T, or if you're doing multiple differences, then you'd have a T as well. Okay, so what I want to be clear about in the specification is these things are treated as fixed, right? They're not looking at the change in tasks within occupations. They don't have the data to do that, right? So they're saying as time evolves, do we see relative growth or decline in occupations characterized by their degree of routine task intensity, their degree of service, their degree of abstract task intensity, right? So that's the activity here. So here you see them one by one, right? So occupations that are, higher and out. So this is a 1 standard deviation higher abstract task importance associated with 1.71 log points in additional growth in hours worked over the period from 1993 to 2006. Right, so I guess they're just doing one difference. Yeah, that's right. And routine declining, service task rising, and then finally offshoreability declining, right? And then various combinations of those things. Right, and what you can see is the ones that are extremely predictive are abstract tasks rising, routine tasks declining. The service task depends on what else is included. The offshoreability tends to be moderately robust and smaller magnitude than the others. Okay. But I think that's that's very much consistent with the hypotheses they came in with. In the second table, they then say, okay, well, let's add the education level of occupations, right? And this is sort of, let's try to look directly at biased technological change by asking whether more educated occupations are growing, right? And a skill-biased technological change. So basically they find this generally is positive, consistent with the idea that that occupations that are more educated on average are growing in size. It turns out not to be robust to the inclusion of these other covariates, and moreover these covariates are robust to it. And interestingly, when they do that for only the lowest paying occupations, right, what you find is the education level is not predictive at all, right? And that's what they're focusing on there is the lower part of the distribution, right? That it's really, what that education variable fails to capture is that you see relative growth in low education occupations, right? And that's what's driving this relationship, and that's why this sort of monotone, education/occupation growth locus doesn't work out, right, in these data, or in most data sets now, is because the growth of occupations is not monotone in education anymore. Okay.
The previous specification, why did they aggregate service in such a, you just told us that services were so heterogeneous, you have this sort of, cognitive skills.
Yeah, I mean, you could have, right. So in the stuff that, in my work with Dorn, we actually sort of scale the service thing by routine to try to get at the sort of low skill services in particular. I'm not sure why they did it that way. Maybe they thought it was sort of the most transparent thing to do. So I'm not, This paper is pretty new to me as well. I mean, but I think, yeah, so you might think they might get more out of that service measure if it weren't actually, you know, high at both tails, right? If it really were picking up at the low end. I agree with that. Yeah, it's a very good point.
Why is the R squared always the same?
Oh, because the, the reason that it is because the R squared is completely dominated by dummies for occupation industry cells and industry country cells, right? So almost all of variation is being taken out by those main effects. So the marginal explanatory variation of these variables is small relative to those cross-country differences, cross-industry occupation differences, right? So you could give the partial R squared for just these variables, it would be relatively small. But that's why that's always 0.89. So if you added in the next 5 digits, presumably they would change. But it's going to be okay, so that's that one, and then the other. So here's the other thing, by the way, that I mentioned earlier, which is this. They want a measure of institutions, and they take a very stripped down view, but maybe it's a good idea. They say, well, let's measure institutions by wage inequality, right? So all else equal. Countries that have higher 90-10 or higher 90-50 or higher 50-10. So here is, again, the dependent variable here is log hours worked. This is and now they're just doing one task at a time and interacting. So here's the abstract task. Here's the main effect of abstract task, right? Still positive. And then is it more important in countries with higher wage inequality? No.
And that's unconditional inequality, not just within sector.
That's right.
Okay.
I think that's right. Here's the routine task, right? It's strongly negative. Is it more negative or less negative in countries with higher or lower inequality? Not as far as we can tell. Here's the service task. Now this is where you might expect to find some bite, right? You might say, well, service occupations are going to become, not grow as rapidly in countries with low levels of wage inequality, right? Because essentially you can't pay low enough wages in those occupations to justify them. So you might think that basically higher wage inequality, so a higher 50-10 would make this more positive, right? But you don't find that, surprisingly. Right? Now, maybe that's because it's not a good service measure, right? I don't really know. But so that's their best effort, or their only effort, I don't know if it's the best they could have done, at measuring institutions, and they don't get a lot of purchase out of that. So let me just, so here's a summary figure from their paper, right? So this is the actual smooth changes in employment by occupation industry, the dark black line. This is the accounting for what they call task bias technological change, TBDC, and that is the double dash line, which is this one. And you can see actually that gets you a lot of the way there. Then they add an offshoring, which is in this thin dash line, and that gets you a little more. And then they add also income. So here, I guess they're trying to, it may be that they're actually controlling for, they're trying to actually look at the effect of this non-homothetic preferences, top income shares. That's not in the table I put up. And that doesn't really get you any closer. In fact, it gets you slightly further away if you look at this line relative to the rest. So, the takeaway of their paper, is that most of the U-shaped growth of employment can be explained by the susceptibility of different occupations according to tasks to increases or decreases in employment, right? So in particular, most of it's coming from the growth of abstract occupations and decline of routine occupations. And the offshoring thing goes in the predicted direction, although by their measure, it doesn't have nearly as much explanatory power in terms of contribution to explaining the overall phenomenon. Now, of course, that's all subject to appropriate caveats about measurement, right? If one of these is much better measure than the other, it's going to tend to have more explanatory power, even if in reality, perfectly measured, they would have the same, or even, offshoring would have more. So I don't think that that's the last word on the subject, but I think that's a kind of an effort to consistently evaluate this hypothesis across a variety of countries. Yes?
I still wonder how many jobs which are in a third percentile in 19
Yeah, I think the ranking, at least at this very coarse level of 22 occupations, is likely to be extremely stable. Obviously, if the finer you break it down, it won't be. But I do think that there are very few occupations that are jumping from the bottom to the middle, from the middle to the top, or vice versa, right? So I think that and this is something they do spend time on. And even in my work with the US data, if we look at occupational rank in 1980, correlate with occupational rank in 2000, or occupational wage, the R-squared is well over 0.9. So these things are relatively stable. Now again, it depends on the level of aggregation. They're also very, what?
Sorry, for some jobs you can easily imagine that people move from the middle to the bottom or the other.
Right.
For example, a secretary
Sure.
who was not very skilled, like 20 years ago, is now in the middle because she has to speak foreign languages and
Right.
to
That's right. That's absolutely right. That's right. So that's right. So I mean, that's an interesting phenomenon, right? Clerical employment has gone way down. Wages in clerical occupations have gone up, right? And I think that a natural explanation for that is the work has changed. The people who still do it are doing something quite different, which is highly skilled work, right? So basically, clerical workers are no longer, typing and filing, right? They're people who sort out, travel reservations, arrange seminars, or people who, go out and deal with complicated problems in the world for you, right? So those are smart people doing non-routine work, right? And in fact, it's easier in the dictionary of occupational titles. It's the one occupation they actually talk about the change. They say, oh, the secretary of, yesteryear was, working at her Smith and what is it? No, not her Smith and Wesson. That was that's what I wanted to say. Smith Corona typewriter, right? With a little rose petal, and smiling and getting coffee for the boss. And the clerical worker of today is someone who's working with word processing, who's searching for information on the internet, who's dealing with outside activities and so on. And I thought that was quite an accurate description. Okay. Good. Other questions on that? Yes.
I just wondered that we had this conversation yesterday that the same jobs that are offshoreable can also be very much the same jobs that are these routine jobs, because they're both kind of easy to teach and easy to codify.
Right. Exactly.
So, and I know that in that paper they argue that at least at the upper tail of the distribution is different, because some jobs that are not codifiable are offshoreable.
That's right. I think that's a really important difference, right? That the offshoring thing goes up higher in the distribution than the automation activity, right? That basically you can offshore, computer programmers. You can offshore people who do engineering, right? You can offshore, potentially radiology technicians, right? But you can't automate those at present, not all the way, right? So, and you see that in this picture, right? That basically the offshoring locus goes further up the distribution, right? And so I think that's absolutely right, that there are certain tasks that can't be automated but are sufficiently well described that they can be packaged up and done by others.
But is it still possible that it takes routine measure some of the variance in this for the middle jobs in the middle of the wage distribution, because they're both offshoreable and
automatable?
Yeah.
Sorry, what was the question? I apologize.
Is it still possible that the routine measure still takes some of the variance from the...
Sure, I mean that...
At least for this.
Absolutely. I mean, but that's what the multiple regression is for, right? To sort of, yeah, they have common variance components. In theory, it's supposed to sort out, those competing explanations. In practice, of course, it's a function not just of the, of the truth, but of the specification and the measurement error and so on, right? So I don't think there's a last word on this question. I think there's actually, if you read the most recent paper by Alan Blinder, he asserts that routinization and offshoreability are quite different in his data, but he's actually comparing a kind of a crappy measure of routinization with a good measure of offshoreability and finding that signal correlated with noise has low correlation. So I don't think I think that they have a lot in common. right? And you can imagine that if it weren't for automation, more things would be offshored. If it weren't for offshoring, more things would be automated, right? So I don't think we know. I mean, I think the interesting part about offshoring is really the movement up the distribution, right? You can imagine it's going to be easier to do, legal work in India than it is to do legal work on your PC, right? So I think that it's really, this is the frontier, and the interesting part about this is the sort of movement into higher skill occupations, where, I mean, there's automation going on there too, but perhaps not as rapidly. All right, so yeah, I think, so this is by no means the last word on this topic, but it is, I think it's a good example. Let me also, I want to actually give you a couple more examples from, just from descriptive examples to give you a sense. When we talk about these occupational change, you may not have an idea of what occupations one actually means, but they're actually fairly uniform across countries. So this is just from US data. This is from our Bureau of Labor Statistics, and these are projecting the occupations that have the largest numerical employment losses or gains over a 10-year period, right? Now, it's not the proportionate ones that are interesting, right? Because proportional change in a tiny occupation is not important. A small change in a large occupation is very important, right? So you really want numerical changes to make this comparison, right? So if you look at the largest projected numerical losses, stock clerks, cashiers, hand packagers, file clerks, farmers, order clerks, sewing machine operators, electrical and electronic equipment assemblers, cutting, punching, and press machine operators, telemarketers, and inspectors and testers. You can see, with exceptions, right, many of these look like routine jobs, right? If you look at the largest projected numerical employment gains, registered nurses, retail salespersons, customer service reps, combined food prep and service workers, office clerks general, I think of those as the high-skilled ones we were just talking about, personal and home healthcare aides, post-secondary teachers, janitors, nursing aides, and waiters and waitresses. Many of those are service occupations, right? So I think that's highly consistent with the sort of concrete examples that I've been talking about. Let me also show you in the two papers with David Dorn, we try to classify occupations also according to their routine task content. And so what we do is we essentially rank occupations using the dictionary occupational title according to routine task intensity, which is essentially the routine over the manual share. And we classify occupations, we take the highest third of those, and we call them the routine occupations, the routine intensive occupations. So just to give you an example of what these are, secretaries, bank tellers, pharmacists, payroll and time-clicking clerks, stenographers, projectionists, boiler makers, butchers and meat cutters, solderers, I can tell you why those are there, but that's what they are, accountants and auditors. So you can see in sort of 7 of 10 cases, those make a lot of sense, right? We're not tweaking the ranking, we're just using what the data say. Then we take the other 2/3 of the distribution and we just divide it evenly according to median wage in the occupation. And just to give you an example of what these are, right? So the high wage non-routine, so this is basically, these are we've divided the remaining 2/3 of the distribution in half, and these are the higher wage ones, and these are lower wage ones. So these higher wage are these are in terms of largest employment shares, right? Production supervisors, teachers, nurses, construction supervisors, electricians, physicians, police, college instructors, and machinery repairers. Then you look at the low-wage non-routine occupations, truck drivers, retail salespersons, supervisors of sales workers, janitors, farmers, nursing aides, carpenters, mechanics, graders and sorters, and waiters and waitresses. Okay. So the reason I give these examples to be very concrete, but here's one thing that's very interesting about these. So if you look at them, right, so the routine occupations are about 45% college educated. They paid in 2005 about $13 an hour US, and the routine task intensity was 1.2 standard deviations above the mean of the entire distribution. So these low-wage occupations, right, they're about 27% college. They pay about $10 an hour. Mean routine task intensity is 2/3 of a standard deviation below the average. And for these high wage, right, they're 54% college. Their mean wage is $17 an hour, and also the routine task intensity is about 0.6 below the average, right? So what I wanted, I think the point I wanted to make here is simply is that just even this very coarse division according to routine task intensity and then splitting on wage shows you, again, that these are concentrated in the middle, and then these other jobs really span the tails of the distribution. Okay, so maybe that came out very much from the Goose and Manning job as well. Okay, Goose and Manning paper, excuse me. So, all right, so that one I don't have to talk about. Good, okay. All right, so now I want to talk about another paper by Ferpo, Fortin, and Lemieux, which is very, very recent. I just came across it. Occupational tasks and changes in the wage structure. And here they're trying to, and so actually this is an important distinction. Everything in the Goose and Manning paper, right, is about employment. Right? It's about employment shares. It's not about wages. So the Ferpo, Fortin, and Lemieux paper is about wages, not about employment. Right? And so I think that makes it useful, and it's using US data only, which I think is a limitation. Right? So first of all, this is just this initial figure I showed you earlier. This is basically just fitting, they actually are taking 45 occupations, and they're regressing changes in wages on initial wage levels. So basically the change in wage over 1983-85 to 2000-2002, right? So over a 15-year period. And for each of these, they're actually doing quantiles of the occupation wage distribution. And let me see if I can give you the intuition of their paper, because we wouldn't have time, and it wouldn't actually be a lot of fun to go through the mathematics of it. But they're going to do a kind of a two-stage regression, where they're going to regress delta wage in occupation J is going to be equal to some alpha J plus gamma times W T0 plus some epsilon J. So this is the initial wage. So delta Wj, right, is going to be equal to Wj T1 minus Wj T0. These would be in logs. And moreover, the way they're going to do this regression is it's not going to be simply a to estimate this regression, you'd have to fit all occupations simultaneously, right? What they do instead is they're going to regress quantiles. So they're going to say Wj of P, let's say of some P Q, where Q is equal to 0.1, 0.2, 0.3, right, to 0.9, right, on a alpha j plus gamma times, and this should be delta W T0 at percentile Q. Okay, so they're asking about the fanning out of the distribution of wages, right, within an occupation. So if this gamma, plus epsilon j, right, q, right. So if this gamma is positive, right, it says that occupations that had higher initial wage levels, right, have more growth and dispersion, right. If it's negative, just the opposite. And then the alpha, of course, is just the common term, so it says, and actually, that's right. And so this gives you essentially the mean change in the wage as well as the change of percentiles. Okay, so so this is going to be a two-stage regression, a two-stage model. So in stage one, they're going to estimate these things, and you're going to get these basically these alpha j hats and gamma, that should be a j, gamma j hat, right, which relates the change in wages within an occupation to the initial wage in the occupation, right? And their hypothesis is that occupations that are concentrated in tasks that have rising value, right, we'll see a rise in both the level of the wage, this alpha, and in the dispersion of wages, right? Because if you have people of different propensities or different skills in a task, and the price rises, then that doesn't just raise the mean, it also raises the dispersion, right? Is that clear? Right, so if you have, you know, for a given level of underlying heterogeneity and skill, a higher price leads to higher wage variance, right? So in the second stage of their model, what they do is they take data from the ONET, and they regress these things on, so basically they do alpha hat, you know, j is going to be equal to plus basically some, and this is over all occupations, plus some, let's use different notation, let's say lambda plus, you know, beta 1 times abstract, j plus beta 2 times routine, j plus beta 3 times offshore j, right, plus some epsilon j. And they're going to do the same thing, they're going to run the same regression for gamma j, right, although they'll use different betas in that point. Oh, sorry, here we go. Aha. Okay, upper bound. Okay, good. So, right. So I just want to make sure, have I conveyed the idea clearly of what they're doing? Right. So there's a two-stage model where in the first stage they're just relating changes in the level and dispersion of wages within an occupation to the initial level of wages and dispersion, and those are, and then they're getting a different intercept and a different slope for each occupation, and then they're regressing those slopes and intercepts on the task contents of those occupations. And the prediction would be that occupations that are concentrated in tasks that are rising in value would see greater growth in dispersion and greater growth in wage levels, and occupations that are concentrated in tasks that are falling in value would see greater declines in average wages and greater compression of wages. Now let me say, I think it's actually it's an interesting exercise. This is not well motivated by a theoretical model of why task returns vary across occupation or why people self-select into occupation. So it sort of takes task returns as given, takes people's occupations or movement into those occupations as given, and it says assume the world works like there are heterogeneous returns to tasks that vary across occupations and there's no self-selection. Okay, so that may or may not be, I mean, obviously that's not perfect, it may be sufficient, I don't know, I haven't even thought about it enough to be sure, but I think it's sort of, it's kind of funny because this paper sort of, you know, gives the model that you might use to justify that paper, but they're definitely written unaware of one another. Okay, so I can summarize the results pictorially very simply. Okay, so this is the intercept of the wage change regression by two-digit occupation, right? And what you can see, not surprisingly, right, is these intercepts are U-shaped. In other words, as you knew, right, occupations that were at the low wages saw rises on average, occupations at the top saw a rise on average, the middle saw falls on average. That is not news. Here's the slopes of the wage change regressions, and again you see basically some rise in dispersion here, decline in dispersion here, or at least in relative terms is a rise. It's still actually a decline in net. So that's a more nuanced prediction of their model that appears to find some support in the data, right? And then they do what's actually kind of a cool exercise, which is they use the Firpo-Fortin-Lemieux unconditional quantile regression. This is a recent econometrical paper that basically develops a technique for estimating quantile models. The typical quantile regression, I don't know how many of you have seen quantile regressions? Okay, great. So the typical quantile regression that you would use, the Conacher and Bassett quantile regression, is a model of the conditional distribution of wages for given x's, right? So in other words, says, you know, it's a measure of the residual dispersion of wages among college graduates with a given year of experience. So if you estimate a regression for example, you'd say like, for example, log W for some, so W for some Q 10 I equals, alpha plus beta 1 times schooling, I plus beta 2 times experience, I plus beta 3 times experience squared I plus some epsilon I, right? Many people would say, okay, so looking at beta 1, what's the effect? Many people would say that beta 1 is the effect of schooling on the 10th percentile of wages. But that would not be the correct interpretation of that model. The correct interpretation of that model is, what's the effect of schooling on the 10th percentile of wages conditional on experience, right? So for someone given an experience, how much does schooling raise wages? But the thing that's complicated about that is, that person, this may be the 10th percentile of people with a given level of experience, but that may have nothing to do with the 10th percentile of the aggregate wage distribution, right? Because people with more experience will tend to be higher in the wage distribution than the 10th percentile, right? So often you're estimating a quantile regression model, and it's giving you conditional quantiles, but you actually aren't interested in the conditional quantiles. You're interested in the unconditional quantile. You're interested in how much does schooling change different, how much does it raise or lower wage inequality, for example? How much does it move the 90th percentile, the 50th percentile, the 10th percentile? So normally to get from here to the thing you actually care about, you basically have to take these results and numerically integrate them up to get the effect on the marginal distribution as opposed to the conditional distribution. So what the Fairpo, Fortan, and Lemieux paper in econometrica does is develop a kind of a two-step technique for finding these unconditional quantiles. Okay, so it's still two steps, but it's a more direct attack on the problem that many people have in mind when they're actually estimating regressions like this. Okay, so I think it's interesting. So anyway, so I mentioned that because then they're going to use this conditional quantile model to attempt to ask what is the effect of tasks versus institutions versus composition on the change in the shape of the wage distribution, okay, over this period. So here is the total change, right? That's the red line, okay? Some part of that is due to wage structure. It's due to composition. In other words, this blue line just reflects the changes in the X's of workers, right? And where that's coming from is rising education and experience of the labor force, right? So overall, that will tend to raise wages at the top relative to the bottom just because the composition is moving favorably, right? So in the US labor force over that period, workers have gotten older and more educated, right? Just because the young workers have gained experience and the average education level has risen somewhat. Now, the green line is then the wage structure change, and notice that actually the wage structure change is more dramatic than the total change because it's partly offset by improving composition. So it says composition constant, we would have even seen more of a U, right? A greater decline in the middle, a greater, similar rise at the top, slightly less rise, sorry, similar rise at the bottom, slightly less rise at the top. Okay, so now the explainable component of this, right, that we're interested in is the wage structure change, right? That's the changes in returns to skills. That's what we're really interested in. The rest of these are nuisance terms for us. Okay, so now this gives you the total effects for the different explanatory variables they look at. So let's see, this is the total effect. Okay, so this is the effect of experience. This is the effect of rising education. So these are having the effect of experiences raising wages throughout this area, lowering here. Education raising wages across the top. The effect of unions, hard to believe, but they claim, right, that unions are an important explanation for not only falling wages in the middle, but rising wages at the top and at the bottom. So that may be true. But the one that the other one that they focus on is technology, right? So this is, when they say technology, what they actually mean. Go ahead.
Are you sure they mean unions or deunionization?
They mean deunionization. Yeah. So basically the decline in union penetration. Sorry. Yeah, that's what I mean.
So that makes sense.
Maybe. I guess I find it hard to believe that A, it's that big, and B, that it works throughout the whole distribution above the sort of, above the 60th percentile, for example. So yes, I mean, I guess they would say, I mean, I think it's plausible the decline in unionization would cause wages at the middle to fall, right, to the extent that a lot of those workers are, highly paid blue-collar workers, right? But I'm not I guess it's this piece of it that I'm more skeptical of. But anyway, that's what the data say. So I'm not quibbling with it. I'm just it's not consistent with my prior. The other thing that appears quite important in their model, obviously, is the technology explanation. And what they mean by technology is these task regressions. So in particular, from regressing these slopes and intercepts on their task measures, they say that the part of the slope and intercept that they can explain through use of these task regressions, right, explains this U-shaped. So in other words, task changes are lowering wages in the middle, raising them in relative terms at the top and at the bottom. And then non-offshoreability, right, so this is they're actually using the blinder measure here. And that also is that also gives a comparable, or sorry, gives a consistent type of pattern. It's negative down here, and it's I think the yeah, I guess it would. I mean, I guess I would say it looks. You can't really tell it apart from their technology explanation, except it has less of an impact over here, and its magnitude is smaller in terms of the size of the dip, right? But I think that's actually their results are highly consistent with Goose and Manning and Solomon's in the sense of they also find offshoring has very much a similar effect to kind of task changes, and again also find that the contribution of that variable to overall changes is smaller than the task contribution they estimate. Now, but what I want to be clear here is what they're estimating here is not employment changes but wage changes. So it's actually kind of interesting that they're finding relatively complementary explanations, right? Now, I don't think this exercise would work nearly as well in non-US data. Right? I don't think if you were to apply this to other countries, you would tend to find something that similar. We know, based on the figures I put up earlier, that basically the changes in employment in the US and the changes in wages look very, very similar. So something that explains one is going to probably tend to explain the other. But I don't think that's necessarily true across most countries. So it will be interesting to try to apply this elsewhere. Right. So okay. So that's that's what I wanted to say. So that's the kind of that's much of the recent evidence that I'm aware of, or the sort of I think the leading recent papers that try to take this sort of occupation task view seriously and apply it to U.S. and international data. So certainly not ready to declare victory, but it seems like a step forward. And it seems like certainly they're getting something out of this that you wouldn't get by simply focusing on education, right? So I think that so now I'm going to move forward. But before I do, any questions on or comments on this sort of stuff we've been discussing this morning? Yes.
I have one question regarding the evidence that you kind of mentioned earlier regarding the link to job mobility and also income mobility. So, I mean, in some sense, the task model does have some implications for that.
Absolutely.
So, do you have any, or are you aware of any analysis regarding the?
Yeah. So I'm aware of the need for that analysis. I don't think there's been much analysis, and I know the constraint that I've run into in trying to do that is that there's no large enough representative data source, panel data source, that would allow me to do that, in the data sets that I'm familiar with. But I think it can be done, absolutely, and I think it should be done. One moment. The paper that I'll talk about at the end of the last lecture today looks at a different way of measuring mobility, which is looking at age structure. And there I think you find evidence consistent with your prior, but I do think it really needs to be done. Right? Now remember that there's multiple ways that that labor markets adjust to change in occupation, right? So some of it is mobility, and some of it is reductions in hiring. Right? So a very easy way to change the composition of your labor force is just to stop hiring. Since there's natural turnover, right, that's going to have the effect of causing occupation to shrink over time. So and there's also, of course, what new entrants do, right? So new entrants tend to grow into growing occupations, young workers, and not go into declining occupations. So adjustment occurs through retiring, it occurs through natural attrition, it occurs through new hiring, and then it of course occurs through displacement. So displacement is not the only channel you would want to look at, but it's a complementary one, right? I think it would be very informative about this question. Yes?
Yeah, I was just saying that, wanted to say that I actually write a paper on this with the Danish.
And what do you find?
You can find some influence. I mean, it's in pretty preliminary stages, but you can find that at least task measures are a good predictor for actually job changes. So people moving down the occupational ladder to more high routine task content applies when people change occupations, a higher manual and interactive.
Interesting. Now, do you see any, is that associated with wage changes on average?
Yes, actually, and I mean, I'm kind of looking at simultaneously because I can identify the changers and the stayers in the occupation, and you can see that the changers that come from a higher routine or occupation, they actually experience also higher wage growth.
Oh, I see. Okay, good.
So then the ones that
and the ones who stay?
The ones who stay. So,
really?
I mean, not the ones who stay in the higher occupation, but the ones who were already in this occupation.
Oh, that's really interesting.
There seems to be some complementarity also with the higher routine.
So that's cool. Yeah. So I think it's great. I think it's a wide open question, and I do think it's the fact that you find movements in that direction is really interesting, and then the understanding the wage thing, of course, is going to be really a challenge, right? But you can do much more with that with panel data than you can possibly do with kind of cross-sectional data, right? So that's, I think you're.
Yeah, I mean we have population-wise.
Yes. Yes. Yeah. No, that's great. That's a great thing about living in a welfare state. It's all recorded. Yeah. No, that's good. Good. Okay. Other questions on that? Okay. So now. Okay. So I hope I've motivated without overselling the idea of sort of tasks as a useful building block. And let me make a point I probably already made 6 times today, which is I don't think tasks are a substitute for skills as a way of thinking about the labor market. I think they're a kind of intermediate layer between there's skills that are acquired, there's tasks, which are the things you do, and then there's output. But in the canonical skills model, which is sort of for example the Katz-Murphy model that we talked about, there's no distinction between skills and tasks, right? Your skill, we can just think that we write the model in reduced form as your skill being the productive input. And that may be fine for many purposes, because if skills are only applied to one task, then it's isomorphic, right? We don't need to talk about the task because we can just talk about the skill and that gets us all the way there. Or it may be the case that everyone of a given skill in equilibrium does only one task, even though there are multiple tasks they could do, or that there's a law of one price for tasks. So in all those cases, right, a skill and a task would be equivalent for measurement purposes, and we wouldn't care about the distinction, right? So it's only worth adding this to the model, right, if we think that it essentially gives us, allows us to explain additional phenomena. And again, I say adding because I think skills are incredibly important, and I think that's a right way to start thinking about it, and you invest in skills to improve your capabilities, but skills are not the unit of work per se, and I think we're in a period in which the mapping between skills and tasks is potentially changing, and that's why we see this kind of non-monotonicity, right? Because we see people of different skill levels, of the same skill level, moving between tasks. And so that gives rise to a more complex picture of what's going on. So tasks, I suggest tasks only as a building block for thinking about the link between what workers bring to the labor market and how they're assigned to activities, and then what wages result from that. Okay, and I think it's an open question, about how you should. There is no standard reference model for thinking about the relationship between tasks, between skills to tasks to wages, right? There is not a standard model. Actually, I will say, Jeroen Acemoglu and I are writing a chapter for the new handbook of labor economics on technology, skill, and wages, and we will attempt, Jeroen will attempt to develop, if not a grand unifying model, then at least a model, a sort of a meta model that tells you what cases to think about, right? Whether you need to think about, what happens when there's bundling, what happens when you can sell your tasks one by one to the market as opposed to only in one job, right? So I think our hope is at least to clarify the set of issues to help people like us who do empirical work to think about what regressions you'd want to run, right? And one thing I think that does come out of this right away is if you think that there's not a law of one price for tasks, like a law of one price for education, then you don't necessarily want to run task wage regressions, right? Because in an education, in a standard Minserian wage regression, right, we think there should be a law of run price for skill, so we should be estimating it, right, by running, log wages on years of schooling and experience squared. But if tasks are a choice variable and you're choosing among tasks, it could very well be the case that in a cross-sectional wage regression, the return to a task would be negative, right? So the return to a manual task would come out negative in wage regression. Why? Well, the average level of task capability of people in manual occupations may be low, right, their potential earnings, but it should still be the case that the return to that task within that occupation might be positive, i.e. it may be that the average earnings potential of someone who's a furniture mover is low on average relative to the market, but still if they have greater physical strength, they probably hopefully get paid more as a furniture mover, right? That would be masked by a cross-sectional wage regression. It might be informed by an occupation level wage regression. So for example, in the Otter-Handel paper, we do occupation level wage regressions, and I was also gratified to see in the Fairpo 410 on the Mew paper, they're also doing occupational level task regressions. So I think there's sort of already, I think people are, sort of intuitively see that if you're going to move in this direction, you have to step away from the kind of standard, you have to step away from the Minserian regression. It only makes sense in the setting where you're talking about a stock variable, an investment good. Okay, so let me, we're going to stop in a minute, but let me actually try to set up the next topic, which is now I want to talk about tasks and trade. And the paper I want to start with is the Grossman and Rossi-Hansberg paper on trade and tasks. And I'm going to work through the model a little bit, but let me kind of try to give you the idea, which is the idea is, and how many of you have actually read this paper? Great. How many have heard of the paper? Okay. All right. So I think it's a pretty relevant paper, and the debate that it's entering is, how do we think about outsourcing? Should we think about outsourcing as just trade by another name? Do we even need a new model for thinking about it? And so if you read, for example, there was a symposium on trade and outsourcing in the JEP, the Journal of Economic Perspectives, a couple of years back, and Jagdish Bhagwati had a characteristically grumpy paper entitled "The Muddles Over Outsourcing." And the point of that paper being, you're all confused, there's nothing new under the sun, outsourcing is trade, trade is outsourcing, end of story. And at some level, I think that's right. You can think about outsourcing exactly the same set of models, but they may not be the models that guide your thinking most successfully to the right things to look at, right? So it's not that you can't interpret outsourcing through that lens, but it may not be the most natural way to do it. And in particular, what the models I put up, the sort of the Lerner diagrams last night, for thinking about trade between countries, basically had these homogeneous production functions, or when I say homogeneous, they were integral, and trade was trade in final goods, right? And so, you just thought about how your, mix of activities within your country changed as the prices of final goods changed. But when we looked at the Che and Wu paper, what you saw was something that looked much more like the breaking down of production functions into subcomponents, right? And the shipment of some of those subcomponents to other countries to be produced there. Now, you could accommodate that idea in the Heckscher-Ohlin model by basically taking a sector and turning it into multiple sectors, right? Each one of them being a different production function, right? And so you could have the Lerner diagram in sort of n-dimensional space, right? And you could get all the right answers that way. But it would be a mess, right? It's not a very natural way to think about it, nor would you know at what points you should break down the production function, right? Where should that dividing line be between the intermediate and the final goods, right? So what the Grossman and Rossi-Hansberg paper does is it says, let's think about the subdivision of tasks across countries, which sets of tasks will be outsourced, and then how that would affect domestic wages and demand for workers of different skill levels as a function of how outsourcing occurs, right? And so that is the thing we'll work through after lunch. Okay, thanks.